Welcome to the PH4410 review on the Sante Fe Artificial Market. In the previous video review, we have discussed the toy icing model of the stock market, and the icing model, of course, is a very artificial toy model, and it is but physicists believe that even though the model is very simple, it captures some essence of the stock market. On the other hand, computational economists tend to develop very sophisticated agent-based models. One of the earliest one to be developed is the Sante Fe Artificial Market, in which there are end traders trading one stock. Okay, and each trader is intelligent, and they can switch between different trading strategies. And they can, so the reason why they switch between trading strategy is because they can form expectations about future returns based on the success or failure of their current strategies. And in the Sante Fe Artificial Market, each trader is represented by a 12-bit binary string. Okay, and the population of strings, which would of course include trading strategies, then evolve according to the genetic algorithm. Okay, and of course in this model, the price of the stock is determined by a market clearing mechanism. Okay, now let me describe the genetic algorithm in greater detail. So here's the genetic algorithm, which form the basis of the Sante Fe Artificial Market. There are three different processes that can act on the population of strings. The first one is mutation, whereby you have a string. Okay, say 1 0 1 1 1 0, and you decide on a random position, say here. Okay, this is the ith position, and then this particular bit will be flipped. So this is 1 0 1 1 0, and this becomes 0 because it has been flipped from 1. Okay, so this is position I. So this is bit flip at random site I. Okay, now the second process that takes place in the genetic algorithm is mating. Now instead of a single string, now it involves two strings. Let's call these two strings N1 and N2, and let's say this is 1 0 1 1 1 0, and this is 0 0 1 1 0 1. Okay, and these two mate. What you do is you decide on where the gene exchange is going to happen. So let's say this is the block that is going to be exchanged between N1 and N2, and as a result of the exchange, you end up with two different strings, N3 and N4. The first one has the same beginning string, bits, and the second one has the same beginning as N2, but after the rest is actually swapped. So this is 1101, and this is 1110. So let me highlight the portion that is swapped. So here it is. This is mating. Okay, and then finally the third process is reproduction. Okay, where you start from N strings and you sample N new strings. Okay, so this is generation T, and this is generation T plus 1, and a string N is selected to be reproduced with probability, okay, Fn over the sum of Fn prime. So here Fn is the fitness of string N. So the fitter the string, the more likely it is to survive into the next generation, and consequently those strings with very low fitness will not reproduce, and they will not be found in subsequent generations. So over time the system can converge towards the maximum of the utility function, or in the case of the Sante Fe Artificial Market, the mating and the mutation constantly generate novel populations, and this perpetual novelty in the stock market is what Professor Brian Arthur and Professor John Holland pointed out in their first few papers describing the Sante Fe Artificial stock market.